This video looks in depth into the issue of coastal erosion and weathering within the Illawarra region, and attempts to build up general knowledge and awareness to the evidence of coastal erosion and the effects it can have on such locations as shown. Erosion is the process in which the surface of the earth is worn away by actions of such things as ice, water, winds and waves. This is an especially important topic for the Illawarra region, with its location on the eastern coast of Australia and the presence of geology and geography of the area, which lends itself to the effects of coastal erosion. Weathering, on the other hand, is the breakdown of Earth's surface by chemical means, as by contact with atmosphere, biota and water. As examples of this, I will show the process of weathering and erosion have destroyed large portions along the cliffs, specifically in Thirroul Beach, Woombarra Rockpool and Stanwell Park, where the forces of coastal erosion and weathering have in fact created current geography of the areas and made for a dynamic and relatively rapidly changing geology. This is happening, as stated, by the combination of weathering and erosional forces being in ideal circumstances, for example, high evaporation and salt deposits for honeycomb weathering, and a large run-up area for wave action, along with geology that currently is highly acceptable to erosional forces. This report shows that in future better planning and care should be taken along the coast areas of the Illawarra in terms of infrastructure to avoid property damage and human risk from the current erosional retreat. To best show this within the video, I'll first demonstrate the different forces of coastal erosion and weathering, then show these forces in play in the three locations listed before, being Thirroul Beach, Woombarra and Stanwell Park. Though these, a risk assessment will be made for the three areas' infrastructure, based on the severity of coastal erosion and weathering by the different actions. So now let's discuss these actions. Currently being shown is a rock platform which shows evidence of the erosional force of rock unloading. Forming joins, this weathering force originates from the removal of great weight that once stood above this rock platform. As the figure on the screen shows, this process works on the fact that the rock no longer has pressure coming from all sides. The erosion of the overlaying rock, which would have once stood above the current platform, has meant the rock has now, with remaining pressure from both underneath and the side, fractured along the top layer. What most people think of when they hear the words coastal erosion is the process described as hydraulic action. Probably the most dominant force in the Illawarra coastal region is the force that is produced by the ocean's waves hitting upon the coast. The Australian east coast is unprotected, and this is true for all three areas inspected throughout the report. Waves have a large distance to build up force and momentum from winds due to the large size of the Tasman Sea. These waves both use abrasion and hydraulic action to wear away the cliffs and coastal geology throughout the Illawarra region. To further compile the hydraulic action effects within the Illawarra is the highly acceptable nature of some of the geology in the area to abrasion. As you can see, a coal seam can leave such a massive cutout in the cliff itself. And look how easily the coal material can be broken apart, allowing undercutting within the region. The next aspect of coastal erosion and weathering requires a slightly harder look at the rocks. See the smallish indents within the rocks themselves? These are formed by a process called honeycomb weathering. This process is somewhat relatable to freeze-thaw, though rather than ice it uses the abundant amounts of salt present in the coastal areas. It occurs where there is dissolved salt present in water. As Rodriguez-Navarro ETLA 2014 states, wind promotes evaporated salt growth between grains on a stone surface, resulting in the development of small, randomly distributed cavities. Next, I wish to simply touch on the aspect of weathering that may not be strictly coastal, can be seen to further influence and drive erosional rates. That is soil creep. The movement of soil downhill through the region can be seen in multiple locations examined. Okay, now it's time to discuss why these erosional forces matter for the Illawarra. Throughout the next part of the video I will visit all three locations, starting with Thirroul, and demonstrate the presence and effects of each of these forces, along with give some form of risk assessment for each site's infrastructure. Currently I'm showing the southern part of Thirroul Beach, where we can see some relatively recently built houses with a wonderful view and a less than wonderful future. We've already spoken about the different factors leading to coastal erosion and weathering in this video, and it's evident that many of these factors are occurring at this location. Let's start by the rock unloading, or possible joining, that we see here down on the rock platform. We have previously explained the mechanisms of both rock unloading and joining, but we can see its application to the Illawarra currently here. As we assess the risk to the structures found in the cliff behind, we can see the beginnings of trouble right here, metres and metres from the houses themselves. And as already discussed, the gaps themselves are incredibly acceptable to weathering, which explains the presence of clean, straight breaks, where one rock piece has been removed completely and another hasn't. Okay, as we move a little bit closer, we can see a continuing problem. That hydraulic action truly creating issues for the area. Notice the undercutting of the cliff above? It's not really present here fully, but we can acknowledge that in times past, material from the cliff have collapsed due to the undercutting. Maybe this over here, the clay evidently exposed, is an indication of the effects of hydraulic action, that close to infrastructure. Remember how I spoke about the geology of the area truly lending itself to coastal erosion? Well, I'm now going to show a fellow student of 6 metres in height planking in the gap left by cliff retreat. The whole body length of space plus some, compared to the unit below. Okay, now let's take a slightly closer look at the area, that perfect honeycomb weathering appearance, left from honeycomb weathering. So this area is not only suffering from hydraulic and abrasive action, but also honeycomb weathering. Even though it's only a small area as we can see, it's still a gradual digression of the hard rock cliff itself. If we needed any more signs of coastal erosion and weathering effects on South Druill Beach area, here it is. An attempt with shotcrete to cover up and protect the area further, and even this is slowly being destroyed. Overall, it can be seen quite plainly here that the area is at medium to high risk. The evident protections shown previously illustrate the area has already become evident to owners and council in this area, and does at least show attempts, though apparently relatively unsuccessful, at reducing erosional rates and securing coastline stability. So here we are at Wombara, just south of the rock pool. Again, I'm showing a rock platform, and evidently on the surface is, yes, you guessed it, joining. This is again a serious issue within the area, and appears a considerable distance from the current structures. Above the cliff is not actually a house, but a graveyard. Definitely a piece of infrastructure best to remain in its current location. As we look out to sea, there is considerable rock platforms proceeding out to sea. Let's see if we can find a good break along the joins. Okay, so here we can see a block from the rock platform has been fractured off its join. Notice the perfectly straight break. This demonstrates how easily weathering within cracks or joins allows the easier movement of material, such as this rock, which is important for the Illawarra, a region so based on the coast. These platforms in many places absorb and protect the cliffs from the majority of storm action, and exist because the material it's made out of, the lithic sandstone, which is considerably more hardy than some of the other layers the cliffs are made out of. Talking about those cliffs. Okay, remember how I said that through there was a shame there was no evident debris from rockfall created from the undercutting? Well, here it is, exactly what I was looking for. We can see simply looking up at the cliff the different levels of erodibility that each sediment layer of rock within the coast has. All it takes is a good sized undercut, and even the strongest, most unerodable rock will find itself a victim of coastal erosion and weathering. Let's see what the debris is made out of. So here this rockfall demonstrates so clearly the consequences for the Illawarra. Like it or not, the whole coastline is a dynamic environment, seen here very clearly. This event of a rockfall would have occurred almost at once, changing the landscape and retreating the coastline even more. The graveyard above may not have any living residents, but it's in everyone's wishes and interests that the site remains intact. Not in pieces such as the debris at the bottom of the cliff. Because of this, one would have to assess the risk as moderate to high within this area. Obviously, even the rock pool, if we look over here, requires severe maintenance, and it won't be long until the exact same is needed for the cliff right here, to try and stop and probably more practically slow the retreat of the coastal area in this area. So now we're at Stanwell Beach. And for anyone with a geology background, this is very recognisable as a dike. Remember how I was discussed at Thrill that the coal seam was deteriorating quicker than the surrounding rock? Well, here we have a similar event happening. As we can see up here, there's some houses, including some relatively new ones, and even though the cliff is made mostly of lithic sandstone, the deterioration of the dike by hydraulic action and abrasion from its position in the coast is increasing the speed of cliff retreat in the area substantially. The dike is leaving holes in the area which is inevitably going to lead to cliff collapse. One side note is the cliff, in contrary to its northern partner, does not suffer from spherical weathering, due to the regularity of erosion upon it. Let's further explain this impact of geology in the area. Here I am demonstrating just how acceptable certain geology is to abrasion and erosion, even without weathering. Just notice how easily in my hand the coal breaks up. You can see how the geology of the area sends itself so well to coastal erosion. The whole region is a sedimentary sequence, and though we won't go into depth now, it has many coal seams throughout the appearance of dikes in some upper layers, which especially as seen in Thirroul, leave vast gaps of overhangs and eventual cliff collapse. Another quite prominent factor here is honeycomb weathering, as we have witnessed in all places. Here it's actually quite large, with some of them a whole hand size in diameter. One further unique aspect of Stanmore Park is the presence of a river, or more accurately two. There is another one further down the beach, but as we only discuss in the southern end and assessing the risk here, we'll focus on this southern leg. If we simply look at the cliff, it can be witnessed that not only is there horizontal retreat from the sea, but also sideways retreat coming from the presence of this river, meaning that the cliff is being attacked on two sides rather than just one. So overall, what is the risk to these properties? Well, considerably high. Coastal erosion is something that every structure on the coast is affected by in some way. In such a dynamic environment, nothing lasts forever, but sadly some of these properties are at the forefront of erosion. Not being an expert myself, I consulted some literature, more precisely a report written on coastal erosion for the Wollongong region. This said report contained a diagram I'm currently showing, which places these properties as having reduced foundation capacity, that is, the ground is drastically less stable by the year 2100. Overall, this topic is very important for the Illawarra, but also the rest of Australia and all other coastal locations in the world. We all love living right on the water, but there is a point where it jeopardises structural safety in such a dynamic environment. Despite previous laws in Australia stating compulsory applications of sea level benchmarks, there is no current legislation in New South Wales, which also indicates a lack of planning in terms of sea level rise and its effects on the dynamic environment and erosional impacts to the infrastructure. Undoubtedly, many of these houses, if not all, have been assessed before being built in terms of possible impacts of coastal erosion, and there is no suggestion that any of these houses were built contradictory to laws or codes in that dictate building in such an environment. Instead, it's suggested that such laws be re-examined and possibly applied on a location-to-location basis. As this report has shown, though similar, no two locations are exactly the same. It's also suggested such laws look ahead to the future. The 2100 reduced foundation capacity may appear decades away, but early prevention and planning will avoid such incidents as houses becoming unsuitable and infrastructure being built in locations known to have a relatively short lifespan in terms of suitable foundations.